the s will be minus 96 minus 12 will give us minus 108. I think this is a correct question, and that is the answer there at D. All right, that is the answer there at D. Now determine dy dx. If s is 1, y is 1. Determine dy dx at s is equals to 1, y is 1 if this thing is equals to 10. Why this may not be too clear, but let us try if we get the answer. If we don't get it, then we have to modify it to the nearest question that it seems like. So we have sy squared plus 3s squared is equals to 10, right? Let us find the y dx. If you differentiate this is like product through implicit differentiation. This kind of differentiation is called implicit differentiation, my dear student. All right, so differentiate this. Now in implicit differentiation, differentiate the s, keep y constant, differentiate y, keep s constant. So when you differentiate x first, it's going to give us 1. Then you use to multiply y square plus. Now it's time to differentiate y. When you differentiate y, it's going to give us differentiate y square is going to give us 2y. I told you that whenever you differentiate y, you put what? The y, the x, then you multiply by what? X. Are you getting it? Differentiate s multiplied by what you have here, y. Differentiate y multiplied by what? X. Plus whenever you differentiate 3s squared, it's going to give us 6x. Differentiate 10 is going to give us 0. So here is y squared plus 2y or 2x y dy dx plus 6x is equal to 0. Is that okay? Now take this 6s to this side. This will give us 2xy dy dx. Take this one to this side, it gives us minus 6s minus y square. Now divide both sides by 2sy. Divide both sides by 2sy. All right. Now at the end of the day, when this cancel this, your dy dx will be minus 6s minus y square then 2xy. Now at the end of the day, you have some point given to you at x is equals to 1, y equals to 1. So wherever you see s, put 1. Wherever you see y, put 1 in that equation, so that your dy dx will be minus 6 bracket 1 minus 1 square divided by 2 bracket 1 1. Now minus 6 minus 1 square is what? Minus 7. So here will give us minus 7 because minus 6 times 1 will give us minus 6. 1 square will give us 1. Minus 6 minus 1 will give us minus 7 divided by 2 times this will give us minus 2. So this cancel this, and here will be what? 7 over 2. So the correct answer to this question is 7 over 2, which is option B. Okay, this is not supposed to be minus 1. This is 1. All right, so here it's supposed to be 2. So here it's supposed to be minus 7 over 2. Here it's minus 7 over 2. Is that okay? So that's the correct answer to that question, which is option C. Option C. All right. Now, given that x, I have another question. S is cos 5 theta and y is sine 5 theta. What is the expression for dy dx? So first of all, we need to look for dx d theta, right? Dx d theta. So dx d theta would be differentiate s with respect to theta. Differentiate this cos 5 theta. According to what I told you, first of all, write this 5 here. Differentiate cos x is going to give us what? Minus sine. Then you write the what? The 5 theta again. So our dx over d theta will be minus 5 sine 5 theta. Now the next one is to look for dy d theta. Now differentiate this according to what I told you. First of all, 5 theta will give us 5. Differentiate sine to give us cos, and then write the 5 theta again. So dy d theta will be 5 cos 5 theta. The s d theta is minus 5 sine 5 theta. Now what do you think will be our dy ds? Dy dx will be dy over the theta times 1 all over the x d theta, right? Exactly. This is the formula you are going to use to solve this question. The formula you are going to use to solve this question, so that our dy dx will be equal to dy d theta is what? Is 5 cos 5 theta. And then the reason why we did it like this is because, now listen, the reason why I gave this formula is because if you look at this, dy ds, dy d theta, 1 minus the s d theta is also the same thing as having theta go up, s come down. So this is in d theta over dx. This can cancel this. You now discover that you have dy dx. That is the reason for this formula. So the y dx will be dy d theta. What is our dy d theta? 5 cos 5 theta times 1 over dx d theta minus 5 sine 5 theta. So dy d theta will be 5 cos 5 theta divided by minus 5 sine 5 theta. 5 can cancel 5. So we are left with cos 5 theta divided by sine 5 theta. And cos 5 theta divided by sine 5 theta is going to give us minus cot 5 theta, because cos theta over sine theta will give us cot theta. So the correct answer here is option D, not the one they shows there. Correct answer there is option D, not the one they shows there. Alright, now the next one is determine the third derivative of this. I don't know if this question is correct because of the the value is not that clear, but let me solve. Determine the third derivative of this. Now whenever you are given something like this, y is equals to minus 3e minus s. To determine the third derivative, first derivative, I'm going to use y prime to indicate the first derivative. First derivative. Now all you just need to be doing for this question is, when you differentiate minus x, you're going to give us minus 1. So differentiate that minus 1, use it to multiply the power you have here. So for this case, you know that whenever you differentiate minus s, it's going to give us minus 1. So you continuously use minus 1 to multiply what you have here. So here, for the first derivative, minus 1 times this times minus 3e minus x, that will give us minus times minus will be positive e minus x. Now second derivative, use this one again, because when you differentiate this, it's going to give us that. So multiply this one again, it's going to give us minus 3e minus x. Then for the third derivative, you see it's still coming back to that first one. Use this one again to multiply this. It's going to give us, when you differentiate, because whenever you have something like this, you differentiate what you have here. When you differentiate 2s, it's going to give us 2. Use this 2 to multiply 3. So the correct answer to this question will be 6e2s. Same thing is what we have here. When you differentiate minus s, it's going to give us minus 1. Use the minus 1 to multiply this and then write everything again. So this will give us what? 3e minus x. So the correct answer to that question is this, and that is option, because they say the third derivative. So you do it once, do it twice, and that's option B, which is very, very correct according to what we have there. Option B. Now determine the value of s at which the maximum point of the function y is equals to, determine the occurs. You're supposed to be occurs at the end. At what point did the maximum value point of the function occur? Now let us determine that. How do you find the point at which the maximum point occur? You find the y dx. So the y dx of this will give us what? 3s square plus what? 4x. Differentiate minus 3 is going to give us 0, so there's no need of writing it. Now you have to equate this equal to 0. At maximum point, at MP, your dy dx is always equals to 0. So it means 3s square plus 4x should be equals to 0. So 3s square. Now you have two values at which that will actually happen if you go with the laws of mathematics. Now the reason why it is like that is because if you want to go with the laws of mathematics, there are two values. Now what is common between these two? X. So here you have what? 3x remaining here, then plus 4 remaining here is equals to 0. So the first value is when s is equals to 0, and the second one is when you have 3s plus 4 is equals to 0, and s is equals to 0, and what? 3s is equals to minus 4. Divide both sides by 3, s is equals to 0, and x is equals to minus 4 over 3. So the correct answer to this question, there's an option there that says minus 4 over 3, which is option A. So you go with that option. Now determine the point of inflection of the function. Now whenever they ask you to determine the point of inflection of any function, all you need to do is very easy. Alright? Now find the y ds and then find the y squared dx, and then use the s squared, then use that one, equate it to 0. So first of all, let us find the y ds. That's what I represented with y prime. When you find the y ds, differentiate s raised to the power of 3 is going to give us 3s squared. Differentiate 2s squared is going to give us 4x. Now how about y prime prime? This you should differentiate this again. So here will be 6x plus 4. Alright. Now at the end of the day, what do you think we are now going to have? You have to, now to get the point of inflection, the square y all over the s square, which I also represented with y prime prime, is equals to 0. So this whole thing here will be equals to 0. So 6s plus 4 will be equals to 0, and then 6s will be equals to minus 4. Divide both sides by 6x, then your x will be minus, supposed to divide both sides by 6, not 6x. So the end of the day, your s will be minus 2 over 3, because here will be 4 over 3, 2 go here, 2 go here, 3. So the correct answer is 4 over 6, I can see here, it's 2 over 3. Alright, so that is that. I think we can go with this one, but in case in the exam, whenever you see a question like this, please know how you go about it, because I told you that something here is not that clear, so I really do not know the approach they took, the correct something, but this is the way to go about a question like this. Alright, okay, way to here, y prime prime 6x plus 4, and then we say we equate y prime prime is equals to 0. So 6s is equals to minus 4. So you divide both sides by what? By 6. Divide both sides by 6. 2 here is 2, 2 here is 3. Okay. One of the options actually carried that, but there's no negative sign. Which option? B. But there's no negative sign. So I think that should be the closest, 2 over 3. Alright. Now for this particular question, I have solved this question in the assignment given to you. So please go through it in the assignment, because it's a very long one and it's going to waste my time, and I will not even want you to solve it in the exam. Just know the right answer to it. So check the assignment, it is there. Now find the equation of the normal to the curve at the point. At this point. Now, for us to find the equation normal to the curve at this point, first of all, we have to look for our dy dx. Now, our dy dx, this implicit differentiation, when you differentiate this, it's going to give us 2x. Then you multiply by y, plus you differentiate y now, that will give us 1 times. Now, I told you that whenever you are differentiating y, you usually put dy ds, then times what? S squared. Plus whenever I differentiate this y square, it's going to give us 2y, you put dy ds, minus differentiate this x, it's going to give us 1, differentiate this y, it's going to give us 1, times dy ds, everything is equals to 0. So that at this point in time, you collect like term. So, okay, this is not dy ds. Here will be 2xy, all the ones that are standing alone without dy ds, pick them to one side. 2xy minus 1, right? Plus, now when this open this, here will be s square dy ds plus 2y dy ds minus dy ds is equal to 0. All right. Now at the end of the day, you can take these ones to this side of the equation. If minus 1 crosses to this side, it will now give us, or first of all, take the y ds out here. So you have the y ds. What do you have left here? S square plus what? 2y minus what? Minus 1 is equals to, take this one to this side. It's going to give us 1 minus 2xy. 1 minus 2xy. Now divide both sides here. Here gives us s squared plus 2y minus 1. S squared plus 2y minus 1. This cancel this. Your dy dx is 1 minus 2xy divided by s squared plus 2y minus 1. Now they gave you the points. X is 0, x is 1, y is 1. So put it into this equation. Here becomes 1 minus 2. 1 will give us the same thing. Here will be 1 square plus 2 bracket 1 minus 1. Here will be 1 minus 2 is what? Minus 1 divided by 1 square is 1 plus 2 is 3 minus 1 is what? 2. So here will give us minus 1 over 2. Now how do you find the equation of the normal? Now for the equation of the normal, this is our dy dx. I think there is still okay. Now for equation of normal, the formula is y minus y1 is equals to minus 1 over m bracket x minus x1. So this gives us y minus, where is our y1? Our y1 is the one that was given initially. It's equals to minus 1 over m. What is our 1 over m? What is our m? Our m is minus 1 over 2. So you have minus 1 divided by minus 1 over 2. This will cancel this, of course, and then you know mathematics now. 1 over 2 will give us 2, right? 1 over 2 will give us 2. Just like 1 divided by half will give us 2. So here it gives us x minus s1 is what? 1. So that y here is supposed to be 1 minus 1 will be, I told you that 1 over 2 will give us what? 2 bracket x minus 1. So that your final answer will be y minus 1 is equals to 2x minus 2. Alright. Now when this one crosses to this side, y will be equals to 2x minus 2 plus 1. Y will be what? 2x minus 2 plus 1 is what? Minus 1. So the correct answer is option C, which is y is equals to 2x minus 1. Y is equals to 2x minus 1. And that is the answer to that question. Given that the displacement of a particle through vertically upward is what is the acceleration in the particle at t is equals to 3 seconds? Now, for displacement, for velocity is change in displacement over change in time. For acceleration, a change in velocity over change in time. So it means you should differentiate 2 times for us to get acceleration from the displacement. So first of all, to get our velocity to be dx over dt. When you differentiate 12, it's going to give us 0. Differentiate 5t is going to give us 5. Differentiate t raised to the power of 3 is going to give us... Are you sure this is t raised to the power of 3 or 3t squared? Let's just try. T raised to the power of 3 is going to give us 3t squared. Alright? So that is the first one. Now, to get velocity now is now 5 plus 3t squared. The next case is acceleration. Acceleration is dv over dt. Now, this will give us 5 plus 3t squared will give us 0 plus, if you differentiate 3t squared, that will give us what? 6t. Alright? That will give us 6t. So our acceleration is 6t. Now, at the end of the day, at 3 seconds, so when t is 3 seconds, acceleration now will be 6